Hi everyone. Today we're going to study addition and subtraction of rational expressions with a common denominator. Let us have the formal definition of adding and subtracting rational expressions with a common denominator. If P, Q, and R are polynomials, where R is not equal to 0, then the rational expression P over R plus Q over R, take note, the denominators are common, and this is equal to the sum of P and Q, the numerators, all over the common denominator R. Also, when we have P over R minus Q over R, this is equal to the numerator P minus Q all over the common denominator R. Let us have some examples. Example 1. Add the rational expressions. The first rational expression, 8x plus 15 all over x plus 5, plus the second, x squared over x plus 5. We can see that our denominators are common, so we can add the numerators. So we have now 8x plus 15 plus the second numerator x squared all over the common denominator x plus 5. Let us arrange our numerator in descending order of powers. It means our x squared comes first, followed by the 8x, and then plus 15. In the denominator, it will be just the x plus 5. Let us factor out the numerator and the denominator completely. The numerator can be factored out into x plus 5 times x plus 3. The denominator is already simplified, so we'll just copy it down here. And then we can see that the x plus 5 is common to numerator and denominator, that we can cancel it out. So when we do that, only x plus 3 remains. So this is our final answer. Let's have example 2. Subtract the rational expressions. The first rational expression is 3m squared all over 6m minus 30 minus the second 21m minus 30 all over 6m minus 30. Again, our denominators are common, so we can proceed with our operation in the numerators. So I copy the 3m squared here and then minus the second numerator 21m minus 30. Take note that we should put this into a parenthesis. All over the 6m minus 30 we copy down here. And then we're going to simplify by removing the grouping symbol. And if we do that, we should change the sign of all the terms inside this grouping symbol. So you see here the 21m is positive. When we remove the grouping symbol, it becomes negative 21m. The negative 30 becomes positive 30. And from here, we're going to factor the numerator and denominator completely. In the numerator, there is a GCF of 3. I will pull out the number 3 to each term of the trinomial. So it becomes 3 is now outside. For the first term, what remains is the m square. For this second term, it becomes negative 7m. For the third term, it becomes 10. In the denominator, there is a common factor of 6. We will pull it out. So the 6m here becomes m, and the negative 30 becomes negative 5. But the trinomial m squared minus 7m plus 10 can still be factored out. So we will factor it again into m minus 5 times m minus 2. We just copy the number 3 down here. In the denominator, the 6, we split it into 2 times 3, and then the m minus 5 is copied here. We will now proceed to cancel some common factors in the numerator and denominator. The number 3 can be cancelled out with the number 3 down here. Also, the binomial m minus 5 is common with the m minus 5 in the denominator. After the cancellation, we will now collect the remaining factors. In the numerator, only m minus 2 remains, so we will copy that over. In the denominator, the number 2 is left, so we copy it here. So one question now is, can we cancel this number 2 and the number 2 in the denominator? There is a note that you cannot remove a term from a sum. It means we cannot cancel that because the number 2 in the numerator is part of the sum. So the m minus 2 over 2 is our final answer. Let us have example 3. We have here two rational expressions. The first is a squared plus 3a all over a squared minus 9, then minus the second rational expression 3a minus 27 over 9 minus a squared. We can see here that denominators are different. In fact, they are opposite of one another. Look at the a squared here. It is positive. There is an a squared on the other denominator but negative. On the other hand, the negative 9 constant in the first denominator, there is a corresponding 9 also in the second denominator but positive. In this case, what we will do, we're going to factor out a negative sign in the second denominator. So what happened is, it becomes like this. I copy the first rational expression and then the minus sign along with the numerator. But in the denominator here, it becomes minus of this binomial a squared minus 9. Let us check if our factoring is correct. If I apply this negative sign inside the grouping symbol, the sign of the terms will be changed. So look at the a squared times this negative sign. I will come back to my negative a squared here. The negative times the negative 9, I will get back my positive 9. So I'm sure that the factoring here is correct. And I also observe that the a squared minus 9 here is now the same with our denominator of the first rational expression. The next thing is, the negative sign here and the subtraction operation will affect the operation and it becomes positive. So now I have new rational expressions to be added and the denominators are common. I can now apply the addition of the numerators and copy the common denominator. So I have here now the first numerator, a squared plus 3a plus the 3a minus 27 all over the common denominator, a squared minus 9. This 3a plus 3a can be simplified into 6a. And from here, factor the numerator and denominator completely. The numerator becomes a minus 3 times a plus 9. The denominator, the factors now are a minus 3 and a plus 3. And then we can now cancel the common factors in the numerator and denominator, and that is the a minus 3. After the cancellation, we will now collect the remaining factors. So a plus 9 all over a plus 3. The next question is, can we cancel the a and the a? Also, can we cancel the 9 with the 3? The answer is, we cannot remove a term from a sum. The a and the 9 here are part of the sum, along with the a plus the 3 in the denominator. They are grouped together as a sum. So we cannot cancel that. So this is our final answer. I hope you learned something from this video. See you again next time.